This kid who kills himself in front of the
I
class.
figured that.
How?
I was wondering about to say suicide as you said that.
Huh?
I was like, suicide in my head.
Oh. Give attention. To the fact that mommy didn't care.
Huh?
What?
This is number 19. And for some godforsaken reason, they think we should do substitution on this.
Yeah, I don't know.
It's absurd.
We do not agree.
Everything is terrible. Is that what you heard?
Yeah.
Did it come from him? Not today.
Never mind.
Oh. That's not bad.
How about this? You want me to really throw you for a loop on this one?
Go ahead.
No?
Not really.
Yes. Don't put it.
You can do it however you want to do it, but I'm just showing you something that I'm seeing. Then you can decide.
Huh?
Anybody see what I did?
No.
No.
Go ahead, Dave, talk to me.
X is equal to 3/4 y. 3/4 y is in the second problem. Just replace it with x.
Ah!
Do you need to do it that way? Absolutely not. Absolutely not. But it is an option. So the 3/4 y is here, and I happen to see 3/4 y up there, and it's just a fluke that I happen to see it. And so I said, well, if 3/4 y is x, instead of substituting 3/4 y for x, I substituted x for 3/4 y. Which therefore means 1/3 x equals 2. So x equals 6. And if x equals 6, then 6 equals 3/4 y. So
Magic.
and the reason I showed it to you is not to try to make you go, ooh, look at what he did, but to just try to realize that there are other options. There are always options. So, you know, I'm not saying that you should be looking for something like this all the time, but, you know, just be aware. You know, I don't know if it makes it a whole heck of a lot easier. I think it does make it a little easier at least, but anyway, different things.
Which equation did you substitute it back into?
This one right here. I kind of reverse substituted.
Yeah, I was like,
Instead of putting this in for x, which is what we normally would have done, what we normally would have done, we would have done negative 2/3 times 3/4 y.
no, I mean when you substituted the 6 in.
I substituted it right here.
Okay.
Oh, yeah. I'm fine with the all points on.
Okay.
That's what you were asking, yeah. Yep. Next. No, we're good? Hey. Good luck with that one.
Yes, bye-bye.
That was, I don't know if it was geometry stuff or algebra 2 stuff, but either way.
Geometry.
I mean, I know it's geometry, I don't know if that was a geometry class, that might have been an algebra 2 class, but that doesn't seem to make a lot of sense to me. Geometry kids never get that. Explain it all you want. Hey, no more of that singing.
I know, it's stuck in my head.
No more.
It's being sung.
So, that's an interesting one. So this is what we've been doing, right? We've been doing the graphing and all that stuff. And that's the beginning of your homework for tonight, but we already talked about that yesterday, so we don't need to talk about it today, correct? Correct. So, why do we do all this stuff?
To be smart.
So we can do this.
Oh boy. Oh boy.
Oh.
Yep.
You guys
Everybody's
excited?
gonna freak out.
Mm-hmm.
But the reality is, in a lot of ways, the word problems, the applications are easier. When you started that problem that we just did with the 1/4 x and 2/3 y and all that stuff, going into the problem, what could your answers have been? Anything. There are no limitations on x or y. So if the answer was actually -5 and -2/3, and you got 7 and 11, there would be no way to tell that your answers are wrong. Fair? True. But my point is, when you're doing these types of things, and we talk about the number of students that are in a class, and you get an answer of -8, what do you know?
Not
Messed
the answer.
up. You know you messed up because you can't have -8 people. You know what I mean? So at least
What do
there's
you
the
mean?
realistic side of things.
I am -8 people.
The other thing is that hopefully, once you start to know how to do stuff, that applying it to real things actually makes it more interesting. And that's how it is for me. Like, I feel very comfortable with how to do substitution and elimination and graphing and stuff like that. I'm very comfortable with that. So once I know that, it's no longer really interesting to do problems like that for me. Let's find something that makes it more interesting. So let's take a look at 56. A pharmacy technician receives an order for 454 grams of a 3% zinc oxide cream. So here's what happens. You go to CVS. And somebody goes to CVS. You go to CVS. And you need and your prescription is for a 3% zinc oxide cream. So you drop off the prescription, you say, I'll be back later to pick it up. And the technician gets it, and he looks in the back, and he goes, okay, 3%. Well, I got 10%, and I got 1%.
Mm-hmm.
He calls you up and says, I don't have 3%, so you're going to have to go to a different pharmacy. Who hears that? His boss hears that. And his boss says, you fix this, or you find another place to work.
That other pharmacy you recommended.
And so he goes, now I got to do math.
I mean, he's a pharmacist.
I know, but that's from my phone. That's this job, by the way. Pharmacy, pharmaceuticals, pharmacy technicians, stuff like that. I mean, some of you could go in that direction in the next 15 years or so. 10 years, I don't know, however many years. You want to be a pharmacist?
No.
It's a lot of money.
Thanks, guys.
What, that's what you want to do?
I want to do something with that. Yeah, maybe chemistry.
It's a lot of money. There's a lot of money in being a pharmacist.
I'm sticking to computers.
So, here we
Be
go.
my pharmaceutical computer technician.
Make sure you don't get hacked.
Yes.
Oh no, my centrifuge has been hacked.
My drugs have been stolen.
So what should we do?
They
So you
broke
look
the
at this
firewall in the
problem.
pills.
Oh, this is like the table.
Oh no.
And you
Yeah.
go,
I so saw that coming.
I don't want
you
to
look
do
at this
that.
and what's your first thought?
No.
Table thingy that we did at the
No, that
beginning
wasn't
of
your
the
first
year.
thought.
No.
What's your first thought when you look at that? No is your first
You
thought.
don't need your meds.
Well, but that's, okay, but that's my point, is that you look at this and it's a mess. So what we're gonna do and everybody freaks out when they see this.
No one likes this.
And I hear you. But the reality is, this isn't done to make your life more difficult. It's not. It's done to make your life easier. Well, this goes off of the assumption that you actually want to get the problem done. So if you're one of those people that just says, I'm not doing it, then so be it. And we do have people like that, and it makes me very sad. But if your thought is, I'd actually like to get the problem done, all we're trying to do here is give you a vehicle to make it easier for you to get the problem done. Watch how easy this is, okay? These are called mixture problems, by the way. And you'll notice that you have one on 55. This is, in a way, a mixture problem. 57.
First quarter
59 is a mixture
flashbacks.
problem. 60 is a mixture problem. So you have a bunch of these. And the mixture problems are all pretty much going to be set up, please, are all going to be set up the same way. Down the left-hand side are going to be the things you're mixing together. Ingredient, 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 however many ingredients you're going to have, and then the last row is going to be the final product. So, what's going to go down the left-hand side?
10%, 1%.
The 1% solution, the 10% solution, and then at the end we'll have 3% solution. Wow, that was hard.
Yeah.
Terrible.
It's not.
Hardest thing I've done all day.
I'm losing my enthusiasm for all of that. So let's. Okay. I'm trying to help. If you don't want me to help, then I'll just go sit back at my desk and do nothing. I can do that. I'm good at that. So let's say that you have a 10% zinc oxide solution. What's that mean?
I know we had like the decimals and percentages involved.
Yeah.
What is a 10% zinc oxide solution? Well, I mean, and I'm just looking for the logical side of it. I'm not looking
It's
at
going to be more potent. and
10% of the solution is
zinc oxide.
pure zinc oxide. Yes? So if we had 50 grams of 10% zinc oxide solution, comma, there would be 5 grams of pure zinc oxide in there. How'd you get that? You started with, which is the total. Total. I don't like total. Amount. I like amount. And then what'd you do with the amount? You multiplied it by the percent. You multiplied it by the percent of zinc oxide. And what did that give you? Equals, right? The total zinc oxide. And there you go, there's your chart. In my opinion, as we start to do these problems, just making the chart is the toughest part. And I think what you're going to find out is everything else in this is easy. Hopefully, once we start to get through this and you start to see this, making the chart wasn't that hard either. I mean, is this hard? Ingredient, ingredient, final. Done. Across the top is going to be pretty much the same thing every time in mixture problems. It's going to be amount times percent of something, whatever it is that we're percenting, equals total of that something. There's your chart every time. If you remember the charts from earlier this year, you'll remember that our goal at this point is not to fill in the whole chart, but just to fill in
What we know.
Spaces we know.
first two columns. First two columns. No, but, and that's with the stuff that we know. And then we'll take those first two columns and we'll use the formula to create the last column. But don't worry about the last column for right now. So look at the first two columns and tell me what we can fill in. 454, where?
The amount of 3%.
The amount of 3% is 454. Problems there. Okay, what else can we fill in?
All the percentages.
All the percentages. Percent of zinc oxide of the 1%.
0.01.
0.01. Percent zinc oxide of the 10%.
0.1.
0.1. I'm going to write it as 0.10 if that's okay. Percent zinc oxide of 3%. That's crazy difficult, isn't it?
Yeah.
No, we haven't. All we've done is fill in boxes with numbers that are in the problem, right? So what don't we know?
The amount.
The amount of the 1% and the amount of the 10%. So what should we do?
X and Y.
Find
X.
out.
Wait, why isn't it X and then X minus that, like
We could, but now that that was back when we didn't do systems of equations, and we didn't know how to solve a system of equations. Now that we do, it's probably easier. And we didn't do x minus, we did 454 minus x.
Yeah.
But that's good, I'm glad you remember that, thank you. Okay, so what's next? Multiply across. What do we get? 0.01x,
0.10y.
10y, 13 point,
Yeah.
like that? Cool. The chart is complete. Was the chart difficult to fill out? It really wasn't. Okay? You put in 4 things that were given to you in the problem. You put an x and a y, and then you just multiply things across. That's all. Now what?
Make it an equation.
Make an equation? Huh? 2 equations. Why 2 equations? 2 variables. 2 variables, we need
2 equations.
2 equations. Can you give me the first equation? X plus y equals 454. What do you think about that one? Logically, I know you like it, you're the one that said it. Logically, does it make sense?
Yes.
We're taking the 1%, we're taking the 10%, we're adding the 10%, and we're getting the 3%. So we just took that and added that to get that. Equation number 2. 0.01x plus 0.10y equals 13.62. Perfect. There are our 2 equations. In most of the mixture problems that we do, that's right where they're going to come from. We suddenly have our system. What don't you like about the system?
Decimals.
Decimals. Can we get rid of them?
Yeah.
How?
Fractions.
We could.
Multiply by 100. Multiply by 10.
Multiply by 100.
They're in the hundreds place.
Because we have 2 decimal places on all of our decimals. That'll get rid of it. So multiply by 100. Watch this. There we go.
I was about to try to.
I won't write the 0, 1. I'll get rid of the 0, 1. And there's our new system after we multiply by 10, or 100, or whatever it was we multiplied by. 100. Do we like our system at this moment?
Wipe away the dots with my finger.
Why?
Because the x is already the same coefficient.
So therefore, we can use elimination. You will notice that at this point, I didn't say, now you need to use the substitution method, or you need to use the elimination method, or whatever. You just look at it and say, well, what's easiest? And in this case, clearly, it's easiest to do the elimination method because we have x and x. What are we going to do? Change the signs. Which one do you want to change the signs to?
Top.
Why the top?
Smaller number.
It'll keep everything positive. So we change all the signs to the top one. We add them together. The x's cancel, which was the whole idea. I see I wrote x. 9y equals 908. Oh, here it is. 100.8. I mean, 900 would be 100, right? So it's 108 and you know that ninths are just that number repeating, right? To find the x, where? Yeah, I'd probably go right there. So if x plus this equals 454, then x has to be 352.1. So what do we find out?
How much of each solution should be put in?
Okay, so how much of each solution should be put in?
100 grams, was it grams? And 352.1 grams.
Holy cow, that should be 353.
What?
I'm sorry. I like borrowed it twice. Sorry about that. So I'm sorry, how much each?
353.1 grams of the 1% and
353 of the 1% and 100, basically 101 of the 10%. Done. Was that bad?
Oh.
It was?
Yes.
But you're doing the same thing every time. Ingredient, total. Amount times percent equals total. Fill in the percents, which will be given to you basically. Fill in the total, use x and y. Done.
It gets confusing to me when all of a sudden we have an amount and then it's like amount plus something and then all of a sudden it becomes like x plus 20 and then that.
Yeah, and some of those you'll have to think about, but I mean,
Rainbows.
like 60 is going to be interesting for you. You just have to be a little creative in setting up your chart.
Not creative.
Well, yeah, because
I doodle rainbows on paper.
is this thing like flashing?
Are you ever
Yes.
bored?
What?
Are you ever bored?
No.
They say boredom sparks creativity.
But 59 is exactly the
Yeah,
same
I'm
as the one
generally
we did,
creative.
isn't it?
I'm always bored.
You just said you're not.
We have an 8% and a 15%. We're trying to make it 12%.
No, I like creating things. That's one of my favorite
60 is going to be interesting because you have gasoline and oil. So I'm interested to see how you guys come up with what charts you make and stuff like that.
My favorite things to mix.
No, I'm not telling you how to do it now. I will tell you how to deal with some problems like 65 and 66, which you will be doing on your homework. Yep. Which are distance, rate, and time problems. So,
Green then. I don't want to use green. Green's yellow.
get started on something and see what it turns into.
Daddy.
This is the longest I've had in any class. Usually it's like 3 minutes to go. We have like 8 minutes. Story time. So, let's say that we are flying from here to Boston. Distance from here to Boston is about 2,500 miles. To fly from here to Boston takes 5 hours. To fly back from Boston takes 6 hours. Why would that be, by the way?
Wind currents.
Yep, wind. You know that wind basically, generalizing, but basically goes from west to east. So you are in the air for less time typically when you fly from here to the East Coast than when you fly from the East Coast to here. Now, time-wise, it's counteracted by the fact that time changes, but we're not worrying about that. So the question is, how fast is the wind blowing? And you have two ways you can do this. You have two ways you can do this. Way number one is you can kind of look at it, squint your eyes, grab your chin. You go 50? That's one way.
How'd you get 50?
Or we can do it the way that you're actually going to get it correct and
Make a chart.
Use a calculator.
I actually have no idea what the answer is here,
What's the
so
question?
what's the wind speed?
Oh, okay.
Okay? So, this is a distance problem. So our equation across the top is something you've used since probably about 4th or 5th grade, which is rate.
Distance divided by.
Wow. Rate times time equals distance. And to anybody who says I have not used this formula, I could not disagree more strongly. If you drive in a car at 50 miles an hour and you drive for 4 hours, how far have you gone?
120 miles.
200 miles. There you go. That's exactly this formula. So you have used it. Okay? Down the left-hand side, what's going to go there? To Boston? From Boston. Which column is going to be really easy to fill in here? Time. Tell me about the time. 5 and 6. We're flying. Now we have to deal with rate. And the problem is that there are two different rates. And this is going to be consistent in the problems that you're going to do for homework. Okay? There are two different rates. There is how fast can the plane fly, which we'll call airspeed. Airspeed is how fast can the plane go if there's no wind. Y we'll call
Wind speed.
wind speed. Okay? If the airspeed, if the speed that a plane can fly is x, and the speed of the wind is y, then what is the rate going to Boston? Why would you be adding y? And the wind is pushing you, basically. The wind is going to make you go faster. So, to Boston, the rate will be x plus y. Coming home, your rate will be,
X minus Y.
there you go. Which means that as we multiply across to Boston, the distance is, now multiply across, I said, 5x plus 5y, and multiply across and you get 6x minus 6y. What do we need now? Two equations. Nothing's changing. Okay? The first equation, 5x plus 5y
Equals 2,500.
equals 2,500. The distance that we're flying is 2,500. The second equation is system. Because in the chart, we just want to multiply across. We don't want to go throwing numbers in. But we always want to multiply across.
Good morning, Ride teachers, please pardon the interruption.
From left to right.
Attention to all students who ride Route 331. That bus will not be picking up here at Mount Point this afternoon.
So you'll be
Students that ride Route 331, you will need to ride Route 332, 335, 320, or 337. Again, Route 331 will not be picking up this afternoon. Students who normally ride that bus route will need to ride 332, 335, 320, or 337. Have a fabulous day, Brian.
No, you're making me go to meetings for 4 hours. I will not have a fabulous day. Sorry.
Probably one of
You good from there?